All right, let's break this down step by step in the simplest way possible. What is a landform? First, let's understand what a landform is. Imagine you're looking at the ground outside. There are hills, valleys, flat areas, maybe even some rivers or rocks. All these shapes and features on the Earth's surface are called landforms. So a landform is just a small or medium-sized part of the Earth's surface with a specific shape. Examples of landforms. A hill is a landform. A valley, a low area between hills, is a landform. A plain, a flat, wide area, is a landform. What is a landscape? Now, if you look at many landforms together, like hills, rivers, and valleys all in one view, this whole picture is called a landscape. A landscape is like a big area of the Earth that includes many different landforms. Example of a landscape. Think of a large park. You might see hills, ponds, and paths. All these together make up the landscape of the park. How do landforms change? Landforms don't stay the same forever. They change over time. These changes happen because of two main processes: erosion and deposition. 1. Erosion. Erosion happens when forces like wind, water, ice, or even gravity wear down rocks and soil and move them from one place to another. Imagine pouring water on a pile of sand. The water washes away some sand, which is erosion. 2. Deposition. After the sand, or rock, or soil is moved, it eventually settles down in a new place. This is called deposition. When the water stops, the sand it was carrying might get left behind in a new spot. How do landforms evolve or change over time? Landforms evolve, which means they change their shape, size, and appearance over time. This happens slowly, over many years. Think of a river. When it first starts, it might be a small stream, like a young river. Over time, it becomes bigger and stronger, carving out a wide valley, like a mature river. Finally, it might slow down and spread out, forming a delta, like an old river. The two important aspects of landform evolution. 1. Transformation of landforms. This means that a landform changes from one type to another. For example, a sharp mountain peak might wear down over time to become a gentle hill. 2. Continuous change. Even after a landform is created, it continues to change. The shape, size, and nature of landforms keep changing due to erosion, deposition, and other processes. Summary with examples. Mountains start as tall and sharp, young, but over millions of years, they can wear down into smaller hills, mature, and eventually they might become flat plains, old. Rivers start as small streams, become larger rivers, and eventually form wide, flat areas called deltas where they meet the ocean. In simple terms, every landform is like a living thing. It is born, it grows and changes, and eventually it becomes something else entirely. The Earth's surface is always changing, slowly but surely. Extra information. Climatic changes. If the weather changes a lot, like it gets much hotter or colder, it can speed up how fast landforms change. Movements of land. Sometimes, parts of the Earth's crust move up or down. This can create new landforms or change old ones. For example, earthquakes can create new hills or change the course of rivers. So, landforms are like stories in the Earth's history book. They tell us how the surface has changed over time. Let's break down the concept of running water as a geomorphic agent step by step in the simplest way possible. What is running water? Running water is water that flows over the land surface. It can be in the form of 1. Overland flow, water flowing as a sheet over large areas. 2. Stream flow, water flowing in a specific path like rivers or streams. How does running water shape the land? In areas where there is a lot of rain, running water is the main force that wears down the land. This is called degradation. 1. Erosion by running water. When water flows over land, it carries away soil, sand, and rocks. This process is called erosion. Imagine rainwater running down a hill. Over time, the water will carve out small paths and channels. These can eventually turn into bigger streams or rivers. 2. Deposition by running water. After the water carries away materials, it eventually slows down and drops these materials. This process is called deposition. For example, when a river slows down as it reaches flatter ground, it might drop sand and mud, creating a floodplain. Stages of river development. Rivers change as they flow from high places to low places. They go through different stages. 1. Youthful stage. The river flows quickly and steeply, carving out deep valleys. This is where you see sharp landforms like waterfalls and rapids. 2. Mature stage. The river slows down as it reaches gentler slopes. It starts to erode its sides more than its bottom, making the valley wider. 3. Old stage. The river flows very slowly over flat land. It deposits materials, filling in valleys and creating wide plains. Key concepts: sheet erosion. When water flows over a large area like a sheet, it causes erosion across that entire surface. Rills and gullies. Small channels, rills, formed by running water can grow into larger channels, gullies, and eventually into valleys. Peneplain. Over millions of years, a river can erode a landscape so much that it becomes almost flat. This flat lowland area is called a peneplain. Even in a peneplain, some hard rocks might stick out like small hills, called monadnocks. Is complete reduction of a high landmass possible? Yes. Over a very long time, running water can completely wear down a high landmass into a nearly flat plain, a peneplain. However, this takes millions of years and depends on many factors, like the hardness of the rocks and the climate. Summary with simple examples. Imagine you have a sandcastle. If you pour water over it, the water will wash away the sand. This is erosion. If you keep pouring, the sandcastle will flatten out. This is like the formation of a peneplain. Some parts of the sandcastle might be harder and stay standing longer. These are like monadnocks. Over time, small streams on a hillside can turn into deep valleys. The Grand Canyon is an example of how running water can carve out deep valleys over millions of years. Extra information. Lateral erosion. In the mature and old stages of a river, it starts eroding the sides of its valley more than the bottom. This makes the valley wider and the landscape flatter. Divides. These are high points or ridges that separate different drainage basins. Over time, running water can erode these divides, making the landscape even more uniform. So, running water is like nature's sculptor, slowly carving and reshaping the Earth's surface over time, turning high mountains into low plains through the processes of erosion and deposition. Let's take a closer look at the youth stage of a river, step by step, and explain each part in the simplest way possible. 1. Few streams and poor integration. What it means. In the youth stage, the river system is just starting to develop. This means there are only a few small rivers or streams, and they aren't well connected. Imagine this. Picture a few small streams of water starting to form on a hillside. They are like little fingers of water moving down, not yet joining together to make a bigger river. 2. Flow over original slopes. What it means. The streams flow over the natural original land surface. The land hasn't been changed much by the water yet. Imagine this. Think of water running down a slide. The slide is still smooth and hasn't been worn down. The streams are like that, just beginning to move over the land, which is still in its natural shape. 3. V-shaped valleys. What it means. As the streams flow, they cut into the land and create valleys that look like a V when viewed from the side. These valleys are narrow and steep. Imagine this. Imagine taking a knife and making a narrow cut into a soft piece of bread. The cut is deep and narrow, just like the V-shaped valleys the young rivers create. 4. No or very narrow floodplains. What it means? A floodplain is a flat area next to the river that can flood when the river overflows. In the youth stage, these areas are either not there at all or are very narrow because the river hasn't yet spread out much. Imagine this. Think of a river running through a steep canyon with little flat land beside it. There's no wide, flat area where the water could spread out, so there's little or no floodplain. 5. Broad and flat stream divides. What it means. Stream divides are the higher areas of land that separate different streams or rivers. In the youth stage, these areas are still broad, wide, and flat because they haven't been eroded down much yet. Imagine this. Picture a flat hilltop between two streams. The hilltop hasn't been worn down by erosion, so it's still wide and flat, not yet shaped into sharp ridges. 6. Marshes, swamps, and lakes. What it means. Because the land is still flat in many places, water can collect in low spots, forming marshes, wetlands with grasses, swamps, wetlands with trees, and small lakes. Imagine this. Think of a low spot in your backyard where rainwater collects and stays for a while. In the youth stage, the land has these kinds of spots where water gathers because it hasn't yet been drained away by the rivers. 7. Meanders. What it means. Meanders are big, looping bends in a river. If they form during the youth stage, they may do so on the broad, flat upland areas. Over time, these meanders can become deeper as the river continues to cut into the land. Imagine this. Think of drawing a big looping curve on a piece of paper. If that curve were a river, it would be a meander. In the youth stage, these loops can start to cut into the land and become deeper, like when you press harder with your pencil to make the line darker. 8. Waterfalls and rapids. What it means. When the river encounters hard rocks, it can create waterfalls, where water falls down suddenly like a mini cliff, or rapids, where the water rushes over rocks quickly, making it rough and bubbly. Imagine this. Think of a garden hose spraying water over a big rock. If the rock is tall, the water might fall down in a little waterfall. If there are lots of smaller rocks, the water will rush over them quickly, creating rapids. Summary with a simple example. The youthful river. Imagine a new river starting its journey down a mountain. It's young, full of energy, and busy carving out deep, narrow valleys as it rushes downhill. Along the way, it may tumble over rocks to form waterfalls, or twist and turn to create meanders. The land around it is still high and flat, with water collecting in marshes and lakes because the river hasn't yet shaped everything into its final form. Extra information. Youthful rivers are like a young child, full of energy and actively changing the landscape. They carve deep into the earth, creating steep valleys and narrow canyons, but they haven't yet spread out to create wide, flat plains. So, in the youth stage, a river is just beginning to shape the land, creating steep valleys, narrow floodplains, and sometimes forming waterfalls and rapids. This stage is all about the river starting its journey, full of energy and power, but still in the early stages of shaping the landscape. Let's explore the mature stage of a river in the simplest way, breaking it down step by step. 1. Streams are plenty with good integration. What it means. By the time a river reaches the mature stage, it has a lot more streams, smaller rivers, that are well connected and organized. Imagine this. Picture a tree with many branches spreading out from a strong trunk. In the mature stage, the river system is like this tree, with many streams, branches, all connecting smoothly to the main river trunk. 2. Valleys are still V-shaped but deep. What it means. The valleys that the river has carved into the land are still V-shaped, but now they are much deeper than before. Imagine this. Think of a knife making a deeper and deeper cut into a piece of bread. The cut valley is still narrow and V-shaped, but now it goes deeper into the bread, just like how the river carves deeper into the earth. 3. Trunk streams are broad with wider floodplains. What it means. The main river, also called the trunk stream, is now wide and has created broader, flatter areas on either side called floodplains. Floodplains are where the river can spread out during floods. Imagine this. Picture a wide river flowing through a flat, open field. This field is the floodplain, where the river can overflow and spread out when there's a lot of water. 4. Meanders within the valley. What it means. The river in the mature stage often flows in big, looping bends called meanders. These meanders are still within the V-shaped valley but are more prominent now. Imagine this. Think of a long, winding road that twists and turns as it goes through a valley. The river does the same thing, making big curves within its valley. 5. Flat and broad interstream areas disappear. What it means. In the youth stage, there were flat areas between streams, interstream areas. But as the river matures, these flat areas disappear as the land gets worn down and shaped by the river. Imagine this. Picture a landscape with hills between streams. Over time, as the river cuts deeper, these hills get worn away, and the land becomes more even and less hilly. 6. Stream divides turn sharp. What it means. The high areas of land between streams, known as stream divides, become sharper and more defined in the mature stage. Imagine this. Think of a knife edge becoming sharper. The ridges or divides between streams become sharper like this knife edge as the river shapes the land more. Ncert. Waterfalls and rapids disappear. What it means. In the youth stage, there were waterfalls and rapids where the river flowed over hard rocks. In the mature stage, these features disappear because the river has worn down the rocks, smoothing out its flow. Imagine this. Imagine a bumpy road with lots of speed bumps. Over time, those bumps get worn down until the road becomes smooth. The river does something similar. It smooths out the bumps, like waterfalls and rapids, in its path. Summary with a simple example. The mature river. Imagine a river that has grown up like a teenager becoming an adult. It has many streams connected to it, making it strong and well organized. The river cuts deep into the land, making deep valleys, and it flows smoothly in wide bends through flat areas called floodplains. The sharp edges between streams stand out, and the once bumpy waterfalls and rapids are gone, leaving the river to flow more gently. Extra information. Mature rivers are like teenagers, still full of energy, but more organized and settled than they were in their youth. They have smoothed out many rough spots, carved deeper into the land, and created broad, flat areas where they can spread out during floods. They are still shaping the land, but in a more refined way than in their youthful stage. So, in the mature stage, a river has many streams, deep valleys, and broad, flat floodplains. The river is no longer wild and rough with waterfalls, but flows smoothly in big loops through a landscape that's been organized over time. Let's dive into the old stage of a river, step by step, in the simplest way possible. 1. Smaller tributaries are few with gentle gradients. What it means. In the old stage, there aren't many small streams, tributaries, joining the main river. The land is now flatter, so the water flows very slowly. Imagine this. Picture a very calm, slow-moving river that doesn't have many little streams feeding into it. The land around it is almost flat, so the river just moves along gently without rushing. 2. Streams meander freely over vast floodplains. What it means. The river now flows in wide looping bends called meanders. These meanders spread out over large flat areas next to the river known as floodplains. Imagine this. Think of a snake slithering back and forth over a big open field. The river does the same thing, making big lazy loops across its flat floodplain. 3. Natural levees. What it means. Over time, the river builds up raised banks along its sides called levees. These are formed by the sediment the river deposits when it overflows its banks. Imagine this. Picture a low wall of dirt that forms naturally along the sides of a river. This wall, called a levee, helps keep the river in its channel most of the time. 4. Oxbow lakes. What it means. Sometimes, the river's meanders become so wide that they get cut off from the main river, forming a U-shaped lake called an oxbow lake. Imagine this. Imagine a river making a big loop, like a horseshoe. Eventually, the river breaks through the narrow part of the loop, leaving behind a separate U-shaped lake. 5. Divides are broad and flat with lakes, swamps, and marshes. What it means. The high land areas between different streams or rivers, called divides, become very flat in the old stage. These flat areas often have lakes, swamps, and marshes. Imagine this. Think of a big flat area of land with lots of water sitting in it, like ponds and marshes. There are no more hills or sharp ridges, just flat land with water-filled areas. 6. Most of the landscape is at or slightly above sea level. What it means. The land in the old stage of a river is very low and almost level with the sea. This means the river doesn't have much energy to cut into the land anymore. Imagine this. Picture a flat beach where the land is just barely above the ocean. The river is now almost as low as the sea, so it doesn't flow quickly or cut deep into the land. Summary with a simple example. The old river. Imagine an old person taking a slow, relaxed walk. The river, in its old stage, is doing the same, flowing slowly and calmly through wide, flat areas. It no longer rushes or cuts deep into the land. Instead, it makes big, lazy loops across its floodplain, builds up natural walls, levees along its sides, and sometimes leaves behind little lakes, oxbow lakes, when it changes it. The land around it is very flat, with lots of swamps and marshes, and it's almost at sea level. Let's break down the concept of valleys into the simplest terms, step by step, as if I'm explaining it to a young child with no prior knowledge. 1. Valleys start small. What it means. Valleys begin as tiny, narrow grooves in the ground. These grooves are called rills. Imagine this. Picture a small crack in the dirt where water starts to flow. Over time, this crack gets bigger and deeper, like how a tiny scratch on your skin can become more noticeable. 2. Rills become gullies. What it means. As more water flows through these small grooves, rills, they grow into larger, deeper channels called gullies. Imagine this. Think of that small crack getting deeper and longer, turning into a bigger trench in the ground where water can easily flow. 3. Gullies turn into valleys. What it means. With even more time and water flow, gullies grow wider, deeper, and longer, eventually becoming valleys. Imagine this. Imagine that big trench becoming so wide and deep that it forms a large, noticeable dip in the land, a valley where a river might flow. 4. Different types of valleys. There are several types of valleys, and they depend on how the land and rocks around them are shaped. A. V-shaped valley. What it means. This type of valley is shaped like the letter V. The sides of the valley slope downwards steeply towards the bottom, where a river usually flows. Imagine this. Picture a big letter V dug into the earth with the river running at the point of the V. B. Gorge. What it means. A gorge is a very deep valley with very steep or almost vertical sides. The width of a gorge is almost the same at the top and bottom. Imagine this. Think of a deep cut in the ground that goes straight down on both sides, like slicing into a thick cake with a knife. C. Canyon. What it means. A canyon is similar to a gorge, but with a key difference. It has steep, step-like sides, and it's wider at the top than at the bottom. Imagine this. Think of a gorge that opens up wider at the top, like a giant staircase made out of rock that gets narrower as you go down. 5. What determines valley types? What it means. The kind of valley that forms depends on the type and structure of the rocks in the area. Example? Canyons often form in flat, layered rocks like sedimentary rocks, which are made of layers of sand, silt, and other materials. Gorges, on the other hand, are usually found in harder, more solid rocks. Summary with a simple example. Valley development. Imagine you pour water onto a dirt path. At first, the water just makes a small groove in the dirt, a rill. But if you keep pouring, that groove gets bigger and deeper, turning into a trench, a gully. If you keep going even longer, that trench becomes a large dip in the ground, big enough for a river to flow through it, a valley. Different valleys. A V-shaped valley looks like a big V cut into the earth. A gorge is a deep cut in the ground with straight sides, like a knife cut through a thick cake. A canyon is like a gorge, but with sides that look like big steps, wider at the top and narrower at the bottom. Valleys are like nature's way of carving paths into the earth over a long time, with each type of valley having its unique shape depending on the rocks and land it forms in. Let's break down the concepts of potholes and plunge pools in the simplest terms, step by step, as if I'm explaining it to a young child. 1. Potholes. What they are. Potholes are small, round holes that form on the rocky beds of streams, especially in hilly areas. How they form. These holes are created by the flowing water in the stream, which carries small rocks and pebbles. As the water swirls around, these rocks get caught in the current and begin to grind into the larger rocks below, slowly carving out a hole. Imagine this. Think of it like stirring a spoon in a bowl of sand. If you keep stirring in one spot, the spoon starts to dig a little hole in the sand. That's similar to how a pothole forms in a stream bed. Number 2. Plunge pools. What they are. Plunge pools are much larger and deeper holes that form at the bottom of waterfalls. How they form. When water from a waterfall crashes down with force onto the rocks below, it creates a powerful impact. This strong force, along with swirling rocks and boulders, carves out a deep, wide hole at the base of the waterfall. This hole is called a plunge pool. Imagine this. Picture water from a tall slide splashing down into a small pool. The force of the splash digs into the ground, making a deep hole where the water lands. That's what happens at the bottom of a waterfall to create a plunge pool. Summary with a simple example. Potholes are like small round dents in the rocky floor of a stream, formed by the swirling of tiny rocks carried by the water. Imagine stirring a spoon in sand and making a little hole. That's like a pothole. Plunge pools are big, deep holes at the bottom of waterfalls, made by the strong impact of falling water and the swirling of larger rocks. It's like a powerful splash digging a hole where it lands. These features are nature's way of showing how water, over time, can shape and carve the land, even in tough, rocky places. Let's simplify the concept of incised or entrenched meanders, step by step, in the easiest language possible, as if teaching a young child. 1. Meanders. What they are. A meander is a big, curvy bend or loop in a river or stream. Imagine a river that doesn't flow straight, but instead whack and forth like a snake. Why they form. Rivers meander when they flow slowly over flat, gentle land. The water has more time to move side to side. They're creating those big, winding curves. 2. Incised or entrenched meanders. What they are. Incised or entrenched meanders are those same big, curvy bends, but they are cut deeply into the ground, forming steep, deep valleys. These are meanders that have been dug into the land over a long time. How they form. Usually when a river flows over a steep, sloping land, it moves quickly and cuts downwards into the land, making the riverbed deeper. If the land is hard, like rock, the river carves these deep, curvy valleys. Incised meander. Imagine a river that used to flow over a flat surface and make gentle curves. Then the land where the river flows gets lifted up, like a mountain growing. The river, still following its curvy path, now starts cutting downwards into the harder ground, making those curves very deep. Entrenched meander. It's like taking a spoon and slowly digging deeper into a curved path in hard clay. The curved path gets deeper and deeper over time. That's similar to how entrenched meanders form. Example. Picture this. Imagine a ribbon lying flat on the table, curving gently. Now imagine slowly pressing that ribbon into clay. As you press, the ribbon goes deeper into the clay, creating deep, curvy valleys. That's like how an incised or entrenched meander is made by a river cutting into the ground. Summary. Incised or entrenched meanders are big, deep, and curvy valleys formed by rivers that have cut deeply into the ground, especially when the land rises or when the river flows over hard rock. These formations are nature's way of showing how powerful rivers can be, carving their paths deep into the earth, even as they twist and turn. Let's break down the concept of river terraces in the simplest way possible, just like explaining to a young child. 1. What are river terraces? Imagine a river. Think of a river flowing through a valley. Over time, the river might cut down into its own bed, making it deeper. Old floors or levels. As the river cuts down, it leaves behind its old floors or levels where it used to flow. These old river floors are called river terraces. They are like steps or flat surfaces left behind on the sides of the valley. 2. Types of river terraces. Bedrock terraces. These are terraces that don't have any loose materials, like sand or gravel, on them. They are made of the hard rock that the river has exposed as it cuts down. Alluvial terraces. These terraces have a layer of alluvial deposits, which means they are covered by materials like sand, gravel, and small stones that the river has carried and left behind. 3. How do river terraces form? Vertical erosion. As the river flows, it keeps cutting downwards into its own bed. Imagine digging a trench in the sand with a shovel. Every time you dig deeper, the sides of the trench are like river terraces, marking where the surface used to be. Multiple terraces. If the river cuts down again and again over time, it creates several levels or terraces. Each terrace represents where the riverbed used to be a long time ago. 4. Paired terraces. What they are. Sometimes these terraces are found at the same height on both sides of the river. These matching terraces on either side of the river are called paired terraces. It's like seeing two identical shelves on both sides of a room. 5. Why they matter. Historical markers. River terraces are like the pages of a history book, showing us where the river used to flow in the past. They tell us how the landscape has changed over time. Example. Picture this. Imagine you're walking up a hill and you see flat steps or ledges as you go up. Each step shows where the ground level used to be before it got higher. Similarly, each river terrace shows where the riverbed used to be before the river cut down to a lower level. Summary. River terraces are flat surfaces left behind by a river as it cuts downwards into its own bed over time. They can be made of rock or covered in sand and gravel, and they help us understand the history of the river's path. When terraces are the same height on both sides of the river, they are called paired terraces. Let's break down alluvial fans in the simplest way possible. 1. What are alluvial fans? Imagine a river moving downhill. Picture a river flowing down from a mountain. When it reaches a flatter area at the base of the mountain, it starts to spread out and deposit the materials it's been carrying. Fan shape. The materials form a wide, cone-shaped area that looks like a fan spread out on the ground. This fan shape is why we call it an alluvial fan. 2. How do alluvial fans form? Coarse material. Rivers coming down from mountains carry a lot of heavy materials like rocks and gravel. As the river flows from a steep slope to a gentler slope, it slows down and can't carry all these heavy materials. Spreading out. When the river reaches the flatter land, it drops the materials it was carrying. These materials spread out in a wide fan-shaped area. Multiple channels. As the river spreads out, it often breaks into several smaller channels called distributaries. These distributaries move across the fan, creating a network of channels. Different types of alluvial fans. Humid areas. In places with a lot of rain, humid areas, the alluvial fans tend to be gentle, with a low slope from the highest point, head to the edge toe. They spread out gradually. Arid and semi-arid areas. In dry places, arid and semi-arid areas, alluvial fans are usually steeper and taller. The fan shape is more pronounced because there's less vegetation to slow down the spread of materials. 4. Why alluvial fans matter. Landform creation. Alluvial fans help shape the landscape at the base of mountains. They can provide fertile soil for agriculture and are important in understanding how rivers and streams deposit materials. Example. Picture this. Imagine a river coming down a mountain and reaching a flat plain. As it slows down, it spreads out, dropping rocks and gravel in a fan shape. Over time, this fan-shaped deposit grows and spreads wider, creating an alluvial fan. Summary. Alluvial fans are wide, cone-shaped deposits of materials like rocks and gravel that form when rivers flowing from mountains spread out on flatter land. In wet areas, they are gentle and low, while in dry areas, they are steep and tall. Rivers on these fans often break into smaller channels and spread out over the fan. Let's simplify the concept of delta. 1. What are deltas? Imagine a river reaching the sea. Picture a river flowing towards the sea or an ocean. When the river reaches the water body, it slows down and spreads out. Fan shape in water. Just like how an alluvial fan forms on land, a delta forms in the water where the river meets the sea. It looks like a fan or a triangle-shaped area of land. 2. How do deltas form? Load of materials. Rivers carry a lot of materials like sand, silt, and clay from the land. When the river reaches the sea, it loses speed and drops these materials. Spreading out. The materials spread out and build up, creating a new area of land. The river divides into several smaller channels, known as distributaries, which fan out across the delta. 3. Characteristics of deltas. Well-sorted deposits. In a delta, the materials are sorted very well. The heaviest materials, like sand and gravel, settle down first near the river's mouth. The lighter materials, like silt and clay, are carried further out into the sea before settling. Clear layers. As a delta builds up, it forms clear layers of sediment. Each layer represents a different type of material that was deposited at different times. 4. Delta growth, expanding into the sea. As time goes on, the delta continues to grow outward into the sea. The river's distributaries get longer, and the delta expands. Example. Picture this. Imagine a river flowing into a calm sea. As it reaches the sea, it spreads out and drops the sand and mud it was carrying. Over time, this creates a fan-shaped area of land in the water. The materials settle in layers, with sand closest to the river and finer silt and clay further out. Summary. Deltas are fan-shaped landforms that develop where a river meets the sea or an ocean. They form as the river slows down and spreads out, depositing materials in layers. The heaviest materials settle near the river, while lighter materials farther out. Deltas grow over time as the river's distributaries extend and more materials are deposited into the sea. Sure, let's dive deeper into natural levees and point bars with more detail, but still in simple terms. Natural levees. 1. What they are. Definition. Natural levees are long, low ridges that form along the sides of a river. 2. How they form. Flooding. When a river overflows during a flood, the water spreads out and slows down. Sediment deposits. As the water slows down, it drops the heaviest materials, like sand and small stones, closest to the riverbank. This creates a ridge along the edge of the river. 3. Characteristics. Location. Found right next to the riverbanks. Shape. Long and narrow, running parallel to the river. Materials. Made of larger, coarser materials such as sand and gravel. 4. Why they are important. Flood control. They help prevent more water from spilling over into surrounding areas during floods. Natural barrier. Acts as a natural protection for the land behind them from floodwaters. Point bars. 1. What they are. Definition. Point bars are areas of sediment that build up on the inside curves of river bends. How they form. Meandering rivers. As a river bends or meanders, the water on the inside of the bend moves more slowly than on the outside. Sediment deposition. The slower water drops off sand, silt, and other materials along the inside bend, forming a bar. 3. Characteristics. Location. Found on the inside curves of river bends, meanders. Shape. Curved, following the shape of the bend in the river. Materials. Made of a mix of different sediment sizes, from sand to small pebbles. Why they are important. Ecosystem. Provides habitats for plants and animals. River shape. Helps shape the river's meanders over time as sediment builds up. Key differences. Location. Natural levees are along riverbanks. Point bars are inside river bends. Shape. Natural levees are long and straight. Point bars are curved to match the river's bend. Materials. Natural levees have coarser materials. Point bars have a mix of sediment sizes. Summary. Natural levees are ridges of sand and gravel built up along riverbanks by floodwaters. Point bars are curved deposits of sand and silt that build up on the inside bends of a river. Both are important for understanding how rivers change and surroundings. Sure, let's dive deeper into natural levees and point bars with more detail, but still in simple terms. Natural levees. 1. What they are. Definition. Natural levees are long, low ridges that form along the sides of a river. 2. How they form. Flooding. When a river overflows during a flood, the water spreads out and slows down. Sediment deposits. As the water slows down, it drops the heaviest materials, like sand and small stones, closest to the riverbank. This creates a ridge along the edge of the river. 3. Characteristics. Location. Found right next to the riverbanks. Shape. Long and narrow, running parallel to the river. Materials. Made of larger, coarser materials such as sand and gravel. 4. Why they are important. Flood control. They help prevent more water from spilling over into surrounding areas during floods. Natural barrier. Acts as a natural protection for the land behind them from floodwaters. Point bars. 1. What they are. Definition. Point bars are areas of sediment that build up on the inside curves of river bends. How they form. Meandering rivers. As a river bends or meanders, the water on the inside of the bend moves more slowly than on the outside. Sediment deposition. The slower water drops off sand, silt, and other materials along the inside bend, forming a bar. 3. Characteristics. Location. Found on the inside curves of river bends, meanders. Shape. Curved, following the shape of the bend in the river. Materials. Made of a mix of different sediment sizes, from sand to small pebbles. Why they are important. Ecosystem. Provides habitats for plants and animals. River shape. Helps shape the river's meanders over time as sediment builds up. Key differences. Location. Natural levees are along riverbanks. Point bars are inside river bends. Shape. Natural levees are long and straight. Point bars are curved to match the river's bend. Materials. Natural levees have coarser materials. Point bars have a mix of sediment sizes. Summary. Natural levees are ridges of sand and gravel built up along riverbanks by floodwaters. Point bars are curved deposits of sand and silt that build up on the inside bends of a river. Both are important for understanding how rivers change and surroundings.